Hey class, how are you doing? Welcome back. Another episode of Math 1 Distance Learning. So we've been working with equations for about the last 7 weeks. And this week we started working with inequalities. So we have equations and now we're working with inequalities. And they're very similar to equations. There are a few differences, and I think you've already done a tutorial, a video tutorial, and we've done a couple of warm-ups, but now I'm going to get into 3 different lessons. So today is working with inequalities part 1. So you should have this handout in front of you. Go ahead and pull that out, and here we go. I'm going to flip over to my DocuCam. Okay, working with inequalities, part 1. Our objective for today is we want to be able to explain the similarities and the differences in the concepts of an equation. So we want to be able to understand the concept of an equation, and we want to look at the similarities and differences between an equation and an inequality. And we also want to be able to interpret and solve inequality word problems. So today we're going to be working on interpreting. We'll do some solving another day. But the main thing for today is we want to be able to look at an equation, look at an inequality. We want to be able to define those, and we want to be able to explain the similarities and the differences. Okay, so let's start with some definitions. You've already seen these definitions. I've already discussed this with you in class, but we'll go over it again. So an equation, it's a mathematical statement that two quantities or two amounts are equal to one another. So when we say equation, right, it's got the word equal, almost got no L, but equal. We're saying that two quantities are equal to one another. They are balanced. They're equal. They're the same. Okay, now a definition for an inequality, it's also a mathematical statement, and it's also involving two quantities, right? A mathematical statement that two quantities, but this time we're saying they are not equal. We are saying that they are not equal, which means one amount is larger and one amount is smaller. They're not equal to each other. Okay, so here are a couple, here are the symbols. So you've probably been seeing these since about 5th grade. So we've got a less than, a greater than, less than or equal to, greater than or equal to, and then this is a not equal to. Okay, so we'll start off with 2 examples. We're going to go and use examples from our nuggets in scales. So you can see in our example here on the left, this left side of the balance scale, this left side is equal to the right side. Now, they don't look the same. You can see we've got 1, 2, 3, we've got 3 gold nuggets here. We have 2 gold nuggets here. This is a 6-pound weight and a 2-pound weight, so they definitely don't look like they're the same, but we know that the balance scale is evenly balanced. So that means that this has to be equal to this. So this would be called an equation. But if we look over here on this one, this is an inequality. We're saying that one side is larger, or in this case, heavier than the other side. So this has 1, 2, 3, 4, 5 gold nuggets. We don't know how much the gold nuggets weigh. Over here, there are only 2 gold nuggets. We have a 10-pound weight. This is a 1-pound weight. So we don't know how much the gold nuggets weigh, but we do know that this side is heavier because our balance scale is showing us that. Okay, so we'll go ahead and solve the equation. So I'm going to take this equation, I'm going to translate it into an algebraic equation. So we've got 3 gold nuggets, so 3n, and there's our plus 2. We know that it's balanced, so we're going to use an equal sign. And then we've got 2 nuggets plus 6. So now if we're going to solve this, we would just follow our basic equation steps. So the first thing I'm going to do is I'm going to subtract 2 from both sides. So these cancel. 6 minus 2 is 4. And now I've got 3 gold nuggets here and I've got 2 gold nuggets here. So I want to take those off, right? We would cancel those off. So if I'm taking 2 off, I want to take 2 off from here. So if I subtract 2 nuggets, I subtract 2, those get canceled. I took those off, and then 3 take away 2 would be 1 gold nugget. So we know that that gold nugget weighs 4 pounds. Each of these weighs 4 pounds. Now, there's only one correct answer that will make this true. This equation has only one solution. And that one solution is the number 4. If I put 4 up here, 4, 8, 12, and then 2 more pounds makes 14. And over here, 4 and 8 plus 6 makes 14. It's balanced. But if I picked any other number, let's say I picked the number 1. If I try to say each of them were 1 pound, that'd be 1, 2, 3. 3 plus 2 is 5. But over here, we'd have 6, 7, 8. So we would know it's not equal. So equations only have one solution. Okay, now let's take a look at this inequality. I've got 5 gold nuggets plus 1 pound of weight, and I've got 2 gold nuggets plus 10 pounds, and it looks like this is heavier. So we're going to say it's greater, right? It's greater. So 5n plus 1 is greater than 2n plus 10. Now I'm going to go ahead and subtract 1 from both sides. I subtract 1, and over here, that's going to give me 9. Now I'm going to take those 2 gold nuggets off. So I'm going to take the 2 gold nuggets off of this side, which means I have to take 2 gold nuggets off of here. And that's going to leave me with 3 gold nuggets is greater than, remember our sign is just staying the same, greater than, greater than, greater than. So 3 gold nuggets is greater than 9. Now I'm going to slide over here because I'm out of room. And I'm going to divide both sides by 3. And that's going to give me the answer n is greater than 3. So that means these gold nuggets, they could be any number of pounds, but it has to be bigger than 3, greater than 3. If I put the number 3 in there, then it would no longer make this true. And this is saying that this side is larger. So this is an inequality, and inequalities have many solutions that make the statement true. So for example, n could equal anything that's bigger than 4. So it could, bigger than 3, bigger than 3. So it could be the number 4, it could be the number 5, it could be the number 6, it could just keep going. 7, 8, we go 10, 10,000, 10 million. So anything that's bigger than the number 3, anything bigger than the number 3 will make that a true statement. Okay. All right. So now let's look at those symbols a little bit more specifically. So I'm going to go to page 2 now. And on page 2, we have these 5 symbols. And so I want to just make sure you know how to read them. So this one here kind of looks like an arrow, kind of, right? The arrow's pointing that direction. We'll talk about that later on in another lesson. But this is a less than. So this says A. We don't know what A is. A is less than B. So the way we'd write that is we would say A is less than B. Okay. All right, let's try the next one. So the next one looks like that right here. So on this one, we would say A is greater than B. A is greater than B. Okay, we'll go to the next one. On this one, now a little bit different. This one kind of looks like this guy, but we have a little equal sign underneath. So this one's a little bit more sophisticated. We'd say A is less than or equal to B. So it could be less or it could be equal. So we would say A is less than or equal to B. A is less than or equal to B, right? This is a less than or equal. Okay, and then on this one here would be right here. A is greater than or equal to B. A is greater than or equal to B. And then this last one, we're just saying A does not equal B. A is not equal to B. We're just saying they are definitely not equal. Okay? Now, these two symbols have another way to say them. So we could say A is less than or equal to B. There's another way to say it. And this is the one that often gets students confused. We could say A is at most B. A is at most B. Now, many of you get confused because you see the word at most, but then you see the word less, and that's a little confusing. So I'm going to give you an example in just a moment. In this one over here, we say A is greater than or equal to B, but we can also say A is at least B. Now that's really confusing for some of you because you see this and you think that that sounds like less, but that's not what that means, okay? A is at least B. So I'll give you an example on that one. Okay, so let's look at this one here, okay? And it just kind of takes a little common sense. You just have to kind of listen to the way it's said. So A is at most B. So here's an example for that, okay? So I told my son that he could eat at most 4 cookies for dessert. Okay, so what I'm saying to him is I'm saying the most you can eat is 4 cookies. You cannot eat more than that. That's the highest. You can eat less, but that's the most. And so the way we would write that is we would say X is less than or equal to 4. So I'm saying the highest, 4 is the most. That's the most. So it could be less than that. All right, so you kind of have to think through that and kind of wrap your brain around that. So I'm telling my son, right, because I don't want him to eat like 20 cookies. He and I both love chocolate chip cookies. So if I said at most 4 cookies, so it'd be that one right there. Okay. Now over here, I told my son that he had to eat at least 5 vegetables for dinner. He's not crazy about vegetables. I'm not either. Some people love vegetables, but I don't really like them, and my son doesn't really like them. So I'm telling him he has to eat at least 5 vegetables. So the way we'd write that is we would say greater than or equal. So what this is saying, this isn't saying less than, this is saying the lowest. 5 is the lowest possible. I'm telling him he needs to eat 5 or more. Okay, 5 or more. He could eat 6, 7, 8, 9, 10 pieces of vegetables, but the lowest amount possible. So at least that means the lowest. The lowest would be 5. Okay, we're going to practice these in the next page of this assignment. We're going to practice those. Okay, here are a few other examples I want you to copy down. So here is an example from money. So 20 is greater than 17. So I could say $20 is greater than $17. I think we'd all agree with that. I could also say $20 is more than $17. Okay, so I have $20 in my pocket and my friend has 17. So $20 is more than 17. Okay, so there's a more than or is a greater than. Okay, all right, here's one from elevation. Elevation is like when you're hiking or you're out in the ocean. Okay, so on this one, a -5 feet below sea level, right? So if you think of like the ocean, like here's a mountain and then the ocean is at sea level, right? So you can either be above sea level, you can hike up the mountain above sea level, or you can dive into the ocean and go below sea level. So -5 feet below sea level is less than 2 feet above sea level. So if you're below, that's less than being above. -5 feet below sea level is less than 2 feet above sea level. Okay. All right, a couple more examples. Temperature. All right, we've had some hot days lately. This week has kind of cooled off. Okay, so here's temperature. So now I have a variable. This one, there was no variable, and the one up here, no variable. but now we have a variable, an unknown amount. So I'm saying today's temperature, we don't know what it is. Today's temperature is going to be greater than or equal to 92. So another way to say it is we would say today's temperature will be at least 92 degrees. So I'm saying the lowest will be 92, but it might be hotter. Today's temperature will be at least 92 degrees, which is the same as saying today's temperature will be greater than or equal to 90 degrees. So at least means greater than. Okay, and then here's one more. All right, money. Okay, so here we have another variable, an unknown amount. All right, so this one, my piggy bank has at most $50 in it. So I'm saying it probably has less than $50, but the most that it would have, it might have 50, right? We put money in a piggy bank. We don't really know exactly how much is in there, but I'm saying the most it will have is $50, but it probably has less than or equal to that, right? So at most is less than or equal to. Okay, so now your homework, I'm going to do an example for you. So filling out these notes is part of your homework, but now I'm going to go ahead and do a couple of these problems. And we're going to be working on using the phrases less than or equal to, greater than or equal to, the phrases at most, and the phrases at least, okay? So we've done worksheets like this before. You're going to get an expression. Then you need to pick which one of these is correct. Is it a less than or equal to or a greater than or equal to? And then you have to figure out which one's the right one over here. Okay, so on this first one, we'll do this together. So here's our expression. We have a variable. X is less than or equal to 5. So that would be a less than or equal to. So we would write it, a number, right? We don't know how much. A number less than or equal to 5. Less than or equal to 5. Now, if we are using the phrase less than or equal to, which one are we using over here? And this is where we need to practice it. Many of you will probably say, oh, it's this one. But I just explained a moment ago that when we have this symbol, we're saying the most it could be is 5. A number that is at most 5. A number that is at most 5. So this one goes with this one. All right, let's try another one here. So this one is a similar symbol. This one looks like this one. So a number less than or equal to -3. A number less than or equal to -3. Okay, now follow the pattern. Here was a less than or equal to. Here's a less than, so we used at most. So over here, we're going to say a number that is at most, a number that is at most -3. Okay, so now you're going to finish up this worksheet. On some of them, you have to fill in here, or here, or here. So you're going to be given one item, and you have to fill in 2 of the squares or rectangles. Okay, all right, so that's your homework. I'm going to go ahead and flip back over here. And if this is a little confusing, that's fine. We're going to keep practicing it. Okay, it just takes practice. You have to keep saying the phrases to be able to understand them. Okay, once you say them enough times and you hear other people say them, then they'll start to make sense. Okay, all right, so finish that up for your homework assignment, and then we will get to working with equations part 2. All right, you guys have a good afternoon. I'll see you. Bye.